I have a really exciting guest today, somebody I've really looked up to. It's Professor Gilbert Strang. He's a professor at MIT. He teaches mathematics. He's made several contributions to finite element theory, the calculus of variations, and linear algebra. He teaches Intro to Linear Algebra, and you can see his lectures freely available through MIT's OpenCourseWare. He did his undergraduate at MIT, and he's a Rhodes Scholar. He got his PhD from UCLA, and since then he's taught at MIT. He's also been a Sloan Fellow and a Fairchild Scholar, and is a Fellow of the American Academy of Arts and Sciences. Dr. Gilbert Strang, it's good to have you here today.
Thanks very much. Thanks for inviting me.
So, how are you doing? I know that I bet your job is a little bit more interesting given the pandemic. You have to teach remotely and all.
Well, that's right. Actually, I was on leave this fall. Right now, I guess, and intending to be in Oxford this fall, but of course didn't happen. So anyway, but I keep busy at home. So
Yeah,
it's okay.
yeah. What does your typical workday look like?
Well, so about in March or April, I realized that I had a new way to start the linear algebra course. So new start, fast start, whatever. So that developed into a book. So that just kept me busy for till September, I guess, March to September. So I enjoyed it all. You wake up in the morning with some idea and develop it. And by 1 o'clock or 2 o'clock, you've kind of said everything you've got in mind, and you go for a walk. That's the system.
Yeah.
Anyway,
Sure.
so it's called linear algebra for everyone. Not too many people know about it yet, but I'm happy to mention it here.
So yeah, that's a really good point. I know that when we learn about math in school, we don't really hear too much about linear algebra. When you think about
Unfortunately, yeah, I was
yes,
asked about that this week. It's really calculus in high school mostly. I do get a few messages from schools that are kind of go quickly, and then some students finish calculus and they're ready for something else their senior year. So then it's often linear algebra. Yeah.
yeah. I mean, why do you think that calculus has kind of managed to be the pinnacle of math education, right? You think high schooler, the highest math you can take is calculus, and that's the end all be all. Or
Yeah.
even in college, like majors, for example, at Hopkins, where I'm if I do a biology major or a chemistry major, they'll ask you to finish until Calc 2 and stop there. Why hasn't linear algebra stuck to the game here?
That's terrible. So my life work is to try to change that, and it's moved from where it was some years ago. But you're right, calculus is still and the basic ideas of calculus. Fine, I have no complaint, but then often it becomes multivariable calculus, which is sort of like more complicated than many people ever use. I frankly never use it. And then comes differential equations, maybe. So yeah, these days linear algebra has just zoomed to the front, and I think gradually courses are catching up. Yeah, yeah, yeah.
I
They
mean,
used to be completely abstract when I took linear algebra at MIT. It was all abstract. It was but beautifully taught, beautifully, but not no applications. So and now it's really very much used. Yeah.
yeah, I'm glad you touched on that because I wanted to talk a lot about this today, and that's I guess your focus when you teach. I mean, it's probably because you teach engineers, but you choose a more computational approach rather than an intuitive one. Like, say, I'm sure you heard of Sheldon Axler, who's came out and spoken against, vanishing determinants in teaching.
Yeah. Well, yeah, sure. Sheldon's my friend. Yeah. And determinants. So I do include determinants, but not at great length. I mean, it's an amazing number, the determinant of a square matrix. Just tells you a whole lot. But like you get a formula for the inverse matrix and so on. But yeah, it's hard to compute, so it's not that useful. Linear algebra is just way used all the time now. If you go on into machine learning or whatever, engineering, computations, all sorts of things. Linear algebra is the key. That's what you actually do. If you have a nonlinear equation, you linearize it. So I think that's the reason that courses have changed. Of course, some faculty, they learned linear algebra in terms of kernels and images and a different language, but that's okay. It is really useful. That's the point. Yeah.
So that's why you sort of try to use it as an instrument to solve problems rather than
Oh
make
yeah.
it be more proof-based.
Sure. Oh yeah. I mean, that's if you have a problem to solve, or like data comes in a matrix and the statistics of a matrix and the work you do to simplify and approximate a matrix by a low rank matrix, that's all everyday work in reality. So, and it's beautiful. So there we are. It's a pleasure.
If you had to like make the case for the average Joe to learn linear algebra, what do you think that they should know, or what math should everybody know, irrespective of what we learn in school or in, as an undergraduate?
Yeah, I'm thinking it's undergraduate. It's showing, linear algebra is showing up in school. So what do I think? Well, I'll mention probability and statistics. And I didn't learn statistics at all properly, but I think that's good. And linear algebra, I just get tons of email from people about linear algebra and about those videos. So yeah, when I sort of got asked to teach linear algebra at MIT, it was a small course for pure math majors, but then we kept that course, but also introduced linear algebra with applications. And of course, that took off to be a very large course right away. Yeah. So it's math departments, most really know now that it's a great topic to teach.
Of course. Yeah. So the thing that fascinates me about linear algebra is that actually recently I was contemplating doing a minor or a major in applied math and statistics here. And I noticed that almost every single upper level requires linear algebra in some way.
Yeah.
So it got me wondering, at least, what is it about linear algebra that makes it so, foundational, something that you need to know to sort of gain intellectual access to some upper level of mathematics? It seems like we can't understand, like more complicated things like algebraic geometry or set theory without having a good understanding of linear algebra.
Yeah, everything begins with the linear case. That's the linear functions. And the point is functions of several variables. So really, multivariable calculus should begin with linear algebra. That's the natural starting point, is a linear function. Instead of ax plus b, you have AA becomes a matrix, and you have vectors and matrices. So, but yeah, it's just, it's a cool subject, and you can sort of visualize it. Well, it maybe not that easy. I always try with a class to think about 10-dimensional space. Like, what are you going to think when when somebody speaks about R10, 10-dimensional space, a vector of 10 components? Well, you can't really. I still visualize it like as a line from the origin, and I don't really get into 10 dimensions. But maybe the point is that with linear algebra, if you see it in 3 dimensions, then the extension to 10 dimensions or any number of dimensions is it just goes through. You don't really have to visualize it, or because the algebra works, and of course the linear case is the starting point for everything.
Of course. So, I mean, it seems like you were really interested in math from the get-go. How did you get into math and then deciding to be a professor?
Well, yeah, I think that's right. I think a lot of us who ended up as math professors, kind of maybe that's the only thing we can do. We enjoyed math always. Thought about math, maybe thought of some like when I was pretty young, I figured out a way so that you could, if you gave me a number like 999, I could square it in my head. I was hoping somebody might ask me. Nobody ever did. But yeah, so it's a little world of its own, and it's a nice people, nice ideas. And with connections to everything else. Like it's a good life.
Awesome. I mean,
so what are you going to do? What subject are you? What's your major at this point?
right now I'm contemplating a major in some of the hard sciences like behavioral biology or neuroscience, but I do wanted to do a minor in,
Neuroscience is great. Yeah,
yeah,
I think yeah.
it has a lot to do with like, some of the big and popping stuff right now with neural networks and such,
Absolutely.
which has linear algebra, right?
It's fun. Oh yeah, of course.
Yeah.
But that's fine.
Yeah. So I know a lot of my friends, I'm at Hopkins, so
Yeah,
obviously a lot of people want to get PhDs,
yeah.
but you get a PhD, you do postdoc, you do research, and then you teach until one magical day you get tenure and then you teach
Yeah.
for years and years. How do you manage to keep linear algebra interesting for you? I know it's one of the many things you teach, but is there a
Yeah.
way you maintain variety?
Yeah, with new ideas, and of course, neuroscience being a younger subject that's that you in your lifetime it's not going to get used up. People will get more and more useful insights into how the brain works. I mean, that's a fantastic scientific question. That's probably the question for the 21st century. Um, and math will be part of describing the answer. Yeah, math has interesting problems in itself, and that's what mathematicians work on. But then it's also a language for everybody, and then you teach people how to speak that language, and you'll be one of them, I'm sure.
I think something I like that you said on Lex Fridman's podcast was that when he asked you about teaching, you said, "I'm not here to teach you. I'm not here to grade you. I'm here to teach you math," which I loved because
Oh, really?
so
Oh,
much
that's
of
good.
grades
That's
today, right?
absolutely true. Yeah, yeah. It's always hard. The class comes in, and then maybe the first week they're thinking, "Oh, what grade am I going to get?" And I try it, and what's going to decide the grade, and is he grading on a curve and stuff. That I just move that grade stuff to the end of the course, and do my best to be fair. But that's not what I'm thinking about when I teach. I'm looking for a good way to understand something new for myself and for the class. So I was on leave this fall, so I'm just sort of thinking about, okay, how am I going to teach in the spring? That'll still be using Zoom. So my idea is to use the Zoom for like give the class a problem and discuss the solution of the problem rather than give a lecture. The lectures are already on MIT OpenCourseWare and on YouTube. So there are new lectures also for more recent courses. And and I think the class time is for people to, for the students and the professor to think together about how to answer questions, how to solve problems.
Right. Here's something that I and many students probably wonder. Why is matrix multiplication defined like
The
that?
way it is, yes. Well, my new book written this spring asks that question and answers it.
Awesome.
Yeah, but because it's a fair question. It's a and also there's more than one way to compute the product. You know, if we're multiplying A times B, usually it's a bunch of dot products. You take the row of A and the dot product with the column of B, and you put that in the answer. And you do a bunch of those dot products and you've got it. But that's not, to me, that's a low level picture. I would much rather see matrix multiplication A times B as using linear combinations of vectors. See it at a vector level, not down in that bunch of numbers. So there you have my speech that every class gets about how to multiply A times B.
Yeah, I know in your lectures you really want to emphasize the linear combinations. It's a really important.
Yeah, that's what you can do with vectors. That you can take linear combinations of vectors. That's basically that's the operation that's allowed.
Right, of course. The funny thing is, in the history of math, even though linear algebra seems to like it should have came first, it actually came
It
after.
should have come first, but it was late. That's right,
Yeah.
very late.
I mean,
It's amazing. Yeah.
do you know who was is there an inventor or a discoverer? I know Leibniz and Newton came with calculus, but we don't
That's
really know
right. So nobody quite gets that level of fame or credit for linear algebra. You know, it was a 19th century development, but then when it got going, it was so natural that it just moved forward. So yeah, so people who take the linear algebra course now. So let me mention the singular value decomposition.
Yeah.
Every linear algebra course talks about eigenvalues. So those eigenvalues apply for a square matrix, but data now comes in a rectangular matrix. And so what replaces eigenvalues? And the answer is singular values. And you have singular, and singular vectors. So anyway, that should be the goal of a good linear algebra course, and Hopkins is certainly good. So I'm sure they get singular values included. Yeah.
If I'm not wrong, singular value decomposition theorem is rotation, stretch, rotation, right?
That's right. That's a good
Right.
way to see it. Yeah, and that every linear transformation is a rotation times a stretching matrix times another rotation. Yeah, yeah, yeah. That's pretty beautiful, actually. Yeah.
I mean, so in every field, I mean, if you ask a biologist, they probably have a favorite amino acid, or a neuroscientist has a favorite, chemical or neurotransmitter. Is there
Yeah.
like a matrix that pops up now and then that you're like, wow, that's really interesting? One that you like?
Well, my favorite is a one that does pop up a lot, and I think some people have seen the picture with cupcakes that my class gave me once on my birthday. So the matrix has twos, it's square, and it has twos down the diagonal and -1 above and below, just above, right above and right below. So 3 diagonals, otherwise 0. Yeah, that's a great matrix. It's simple and it shows up everywhere. So that's my favorite. Yeah. Yeah.
Kind of like pi or e to the x kind of thing.
Yeah, exactly. Like that's the equivalent of e to the x. Wow. E to the x is super, super important. That's the only candidate for calculus as being the great thing that's not part of algebra, but then it comes into calculus. Yeah. Anyway, the beauty of linear algebra is it's got all kinds of interesting matrices.
Right, of course.
Calculus, you just take the derivative or you take the integral. Two choices.
Yeah.
And whereas matrices are kind of like amazing variety of matrices.
As a stats fan myself, I will join in on anyone who wants to bash calculus. I will take it.
All right, we're a team.
Yeah, of course. All right. So something I'd like to ask all of my guests before we close out
Sure.
is, what's your favorite quote? It could be something you live by, something close to your heart, or just even some words that you're really thinking about nowadays.
Yeah, well, okay, I'll just do something that I think about, which is like the reason for a proof. Why, if you understand something, so why do mathematicians want to give a proof? And we're mathematicians are all pretty much agreed on what that means.
Right.
But why do we do it? So anyway, here's my little thinking about a proof. Why do we have it? Okay. So the question is, why should we want to find a proof? The reason is, a proof means that we have not just seen the pattern and believed it and liked it, but understood it. So for me, a proof is the final step in really understanding an idea. So that's now my answer to the question of why do we have a proof, and what does it achieve? Yeah.
Thank you. I'd like to follow up on that, but I know I respect your time. But I know that for me personally, knowing the proof of something is kind of a way to help me understand the formula rather than just memorizing it rotely.
Good. That's right.
So yeah, so it's wonderful words. Absolutely great talking to you. It's been an honor.
Oh, thanks, Yuri. Nice to talk to you.